All right, how's everybody out there? Been a long time since Aerospace Rocketry has posted some videos here, but we haven't been flying. The weather's been really, really cold, and we didn't get down to the big field. We usually fly down in Maryland at MDRA, but we just haven't been there. It's just been really cold, and so I missed the first few months of launching at the large field, but we're coming playing on red glare. I will be there March 29th on Saturday and wanted to talk to you about our project. Now, some of you have seen this. I posted a few things on this Starship project that I've been working on. My daughter does all the logos for me and mission patches. Um, and I'll show you that here. I'm going to also post pictures as I talk about this project that we did with Starship. So started out, of course, we got to scale these things down, right? Of course, a Starship is 30 feet in diameter, so we figured out how many inches. And it just so happens that a 148 scale Starship is 7.5 inches, which is perfect for Loke tubing. So thank you, Loke, out there. Appreciate it. You guys make great stuff, and we use you all the time. So we took these tubes, and of course, I fiberglass everything. Not that I have to worry too much about speed, strength, but mostly after deployment, sometimes these pieces tend to bang together. So the Starship is going to be 7.5 inches in diameter, and it came out to 109 inches tall. So we have all of this stuff. We've been working on this. I think we started it in January 2024, which makes sense because in December, right around the holidays, I always ask all my family members to give me money, give me cash so I could buy rocket stuff. So that's why this project started in January. And again, we started with some Loke tubing, 7.5. We fiberglassed them. And my son in law wanted to get involved, Adam. You will see him in some pictures here. And he wanted to get involved with this project, which I thought was really cool because usually I'm building rockets by myself. My son is, into going and helping me out, but not into building. And he doesn't have a lot of time anyway. So it was good to see somebody come and make a joint project out of this. So the lower portion of the Starship we did, which is the booster. I am using a 75 millimeter motor mount. I use bells, actual bells, like I did on my Falcon 9 because I love to build scale rockets. So my Falcon 9 is 124 scale. I got a full scale Sidewinder, full scale AMRAAM that I got my level 3 on. But I use bells and painted bells and around all the whole outside to make it look like there's a ton of engines in this thing, which is what Starship has. I think they have 36 total. And then the center, 75 millimeter. And we're going to be running this on an M motor, which I'll get into a little bit later on. So I wanted to make this as authentic as possible. And one of the things that we know, especially if anybody out there has watched the last two Starship launches, 7 and 8, they were able to capture the booster, and you see that flame going back and forth to stabilize it, and it gets caught in between those chopsticks. Well, we stabilize our rockets in this hobby with fins. So how do you make it look as authentic as possible? Well, you don't want to see the fins, so I use acrylic. Plexiglass. I did this on my Falcon 9. Works great. Now, acrylic doesn't stick very well to epoxy. So what I did was I drilled holes all along the root of the fin where it connects to the motor mount. And I had the epoxy actually flow through those and back onto the motor tube. It's really sloppy. You'll see some pictures here. But it made them super, super strong. I even bounced it on the floor accidentally, and those fins didn't move. They're really strong. They're really in there through the wall, very tight. The other thing on the Starship is that the metallic look, right? So I'm thinking, how am I going to get this? I didn't want to use standard silver paint. It looks kind of cheapy. So I found a car wrap that was stainless steel, I think they call the color. And I wrapped the lower portion of the tube to make it look like the Starship. And then I ran some wood dowels and things like that to make the fuel lines, make it look as realistic as possible. So we put that together. We of course, we cut our slots and put our fins in really, really strong. And then we inserted the whole assembly into the lower portion of the tube. Now this rocket's going to end up being besides 7.5 inches in diameter. It's going to be 109 inches tall, and that's the full sustainer and the Starship on the top. And again, this is a 2-stage. So we should come in somewhere around 60 pounds. If we, with battery weight, we might be a little bit higher. But our first stage booster will be an M1297. I'm looking forward to firing another M. That's really cool. And that fits perfectly in a 75 millimeter motor mount, motor casing. And the upper stage will be a K695R. Now, we're not too worried about a 5-to-1 ratio on the second stage because the speed is already going, and it should keep the rocket nice and stable. And speaking of stability, our full booster Starship together, our stability is well over 2.0. Very great, very stable. To me, in high power, big rockets need to be stable. And you can't, I see some of these guys shooting big rockets and they're doing S-turns or they're going sideways, they come off the pad. Stability is so important. Center of gravity, center of pressure, two of the easiest things to learn. It's, the center of pressure can be calculated on programs like OpenRocket, based on your fin size, body size, the length of the rocket, and center of gravity really is just balancing the rocket. Get a buddy if you got a heavy rocket and bounce it on a rope, and that's your center of pressure. And as long as that's, equal to or more than the body diameter in length away from the center of pressure, you're good. So that's important. And speaking of that, the entire stack is very stable. However, the Starship has a lot of things going against it for stability reasons. One, it's fat. Two, it's short. And three, there's some upper fins that are in the Starship. And you see the picture of the real one here. That's got those fins, and they kind of tend to move this way and that way during reentry. And these are fixed. So that pushes the center of pressure forward, which we really want to get as far back as we can. So that was a challenge in itself. Now, every rocket has to have at least 3 fins. I put 4 fins on the Starship. Now, the real Starship only has 2. And they really just serve as kind of guiding it in during reentry. But mine, of course, have to be for stability. So I just couldn't get it quite right. We put nose weight in, lots of nose weight. Still couldn't get that center of gravity far enough up or the center of pressure far enough back. So after I had the 4 fins on, I had to add about an inch or so to each fin on the lower section. So it's a little bit off scale. And I also had to take the upper fins and trim off about a half inch to get that center of pressure moved back far enough. And we got 1.0, 1.2, somewhere in there for stability for the Starship. So we should be good. And that's with the motor in place. So that was the toughest challenge, is getting the Starship stable by itself. Now we have a lot of things going on here. We got an M1297. We're going to stage to a K695R. Nice red line. It's got some pretty good power, so that's going to be enough to push this thing. Simulations show it at about 3,900 feet. So the booster will stage at about 2,000 feet, 2,400 feet, somewhere in there. And we're going to have a standard ejection charge with a full parachute. We're not going to do a drogue. We're just going to blow the full parachute. But here's the cool thing. On the real Starship, the grid fins, and everybody knows the grid fins from the Falcon 9, as it's coming down, they kind of steer the rocket back down towards the pad or out to the ocean on the landing platform. The Starship's grid fins are fixed, even during takeoff. You see them sticking out. Now, part of the reason for that is the mechanism to make them fold in and fold out is heavier for the offset of launch to weight ratio than the drag that these things create when they're sticking out. So I guess Musk decided to not put these mechanical things in and just keep the grid fins out during launch, which doesn't affect the launch. There's so much power in a Starship. However, I wanted ours to open up. So I got together with my 3D printer guy. He made my nose cone for me. He made the Starship nose cone. And we came up with an idea. The grid fins have spring-loaded, right, using like Molly springs. And we had a pin on the bottom that goes into the body tube. And when you set the coupler where the parachutes are going to be down here. You put the coupler in, it's going to hold those grid fins in place. During ejection charge on the booster section, that's going to blow out that section, release those pins, and we're going to hopefully see these grid fins come out. Kind of make it look real. Now, I don't know if it's going to survive the landing because of the gentle mechanism that's in there and the hinging that I had to do to get these to work. So I'm hoping it survives once it touches ground and falls over, but we'll see. But we should get some pretty good video, which, speaking of which, we have 2 Mobius cameras on the Starship. We got one from on the Starship looking down, so hopefully we get to see that cool separation. And we have another camera, looking up. Hopefully we see the grid fins and we see the separation and the Starship go. I think we're going to get some pretty cool video if it all works. And they're Mobius cameras. The camera shrouds that I'm using. Thank you, Brian, by the way. He 3D printed them for me and they fit perfect for these Mobius 4K cameras. And we're going to be utilizing that. We also have a lot of electronics on board. So the booster section has an RRC3 main for chute deployment and RRC2 as a backup. I always like to have backups on these huge projects just to make sure that we get our chutes when they're supposed to come out. The Starship has an RRC3 also and an RRC2 and a PET Plus for staging. And this is Missile Works. So thank you, Missile Works, for that. It has an inertia detector, which means that when it feels that first stage motor cut off, a timer starts and will ignite our second stage. So simulators showed at 3,900 feet using Open Rocket for a total altitude. And we're going to try for the first time a chute release on the upper stage. So we want to bring it down to about 1,000 feet, and then we'll hopefully this thing will open up and get our main chute at 1,000 feet. I did mention I started work on this in January 2024. We were finished with this whole thing by May of 2024 because we wanted to shoot this originally at LDRS on June 8th. I think LDRS went from June 6th to, was it June 6th? No, it was like June 6th to June 9th up in New York. And we were planning on going there, but the weather turned out to be horrible. Rain, mud. They did get some flights off, I think, on Saturday, but winds were pretty high. So it would have been a waste to go up there because I want the weather to be very cooperative, especially on the first flight of any rocket. I want to make sure all the parameters are set and the launch conditions are perfect before you make an attempt. So, but we were going to go up there and do it at LDRS 42, which would have been great, but we're going to do it at Red Glare. So we're going down there on the 29th. Launch time is somewhere between 11 and 1 o'clock. We're going to get there about 8:39, set up camp, test everything, make sure we have our chutes packed correctly and everything's ready to go. And hopefully we can launch between that 11 and 1 time frame. So any of you photographers out there, keep an eye out for Aerospace Rocketry. Come by our tent, by the way. I'll have an Aerospace Rocketry flag. I'll have an American flag on the other side. We have a pretty good sized camp, tent, table, the whole thing. Come by, see the Starship. I think you'll really like it. It's pretty cool. So we're looking forward to getting down to Red Glare. And hopefully our launch time is somewhere between 11 and 2, 11 and 1. We'll see depending on the lines and how many people are there. We're going to be on the away cell, so I don't expect too much delay. But any photographers out there, I'm going to have some GoPros set up, but I would love to see some great photography from you guys out there. And if you can get long-range shots, the 2-stage of the staging process would be even more impressive. So I'd be grateful to you all and be happy to purchase some pictures from you if you get some good shots for me. But that's what we're looking at. We're looking forward to really getting this in the air. We're doing some final preparations a few days before launch. We're going to run the electronic tests again to make sure everything's ready to go and hope to see you there. By the way, in case you're looking at this cup here, my buddy Bill and I decided to do a podcast. We got about 14 episodes in now. And, we just talk about some politics. We try to make it light, humorous, just talking about everyday events. It's called the Bill and Joe Show. and just look us up on YouTube. We're actually, the audio portion's on everything. We're on Spotify, iHeartRadio, Apple Podcast. We're all over. On the back of this are scannable QR codes. But if you just search for the Bill and Joe Show, really appreciate it. Check that out too. Make sure you subscribe to this channel and like, and we will see you at Red Glare. Looking forward to it.